Okay, so in the last video there we discovered that it is possible to find a little gimmick, or that it is possible, excuse me, to factor a sum of cubes and a difference of cubes. So what we're going to do now is try and figure out what the gimmick is that we can use to quickly factor these. So we're going to do it the old way, or the long way, excuse me, which is to use the factor theorem like we've been doing the last couple of days. So the first thing we have to do is guess a factor, and then we'll do a test, or we'll guess a root, excuse me, and we'll do a test to then see if that root spawns a factor. So we just need to guess a number that's going to get us a 0. For no apparent reason, I'm going to guess -2. And if we go -2 cubed plus 8, of course negative cubed stays negative when we have -2 cubed stays negative plus 8. And of course we get 0. And so x plus 2 is a factor. Okay, good. So now, since we know it's a factor, we're going to go off and use synthetic division to simplify this, or to divide. So we're going to go off here and write down 1 for x cubed, 0 for x squared, 0 for x, and 8 for the constant row. And since the factor is x plus 2, we need to write the root of -2 here. Synthetic division tells me we keep this as 1. -2 times 1 is -2. We add is -2. Multiply, we get +4. Add, we get 4. Multiply, we get -8. And not surprisingly, we get 0 as a remainder because we already knew it was a factor. That means what we have is x squared minus 2x plus 4 is the quotient if we actually did the division. So, taking the division statement now, we would say that we started with x cubed plus 8. We knew that it can factor into x plus 2 times, and then whatever's left over is x squared minus 2x plus 4. Now, the question is, can we look at this? We know that that's the answer. That is the factor. We were able to factor it. The question is, how can we come up with that quicker without having to actually go through the long division? So I'm going to give you a second, and I'll ask the supply teacher to pause the video here in a second. And what I want you to do is just stare at it, maybe talk with your neighbor, and see if you can see a connection between your question that you've been asked to factor and this answer here. Okay, that's a pretty easy connection there. And then based on these two answers, if you can make a connection between where this number comes from, where this number comes from, and where this number comes from. So if you could just pause it for a second, then give you a sec to see if you can come up with the connection. Okay, so if we look at this, the beginning I think is pretty straightforward. These numbers come from the cube roots of both numbers, the cube roots of both numbers. So the cube root of x cubed is x, and the cube root of 8, what number do you multiply by itself 3 times to get 8? The cube root of 8 is 2. So just like before when we had the square root, we had the difference of squares, we had the square root of the first, square root of the second. This is the difference of cubes, so it's cube root of the second, or cube root of the first, cube root of the second. Now, how do we figure out where these numbers come from? The other half. Well, if you notice the connection between x and x squared, and 2 and this, well, it turns out that this, the connection is, of course, both of these numbers get squared. So x squared is x squared, And then 2 squared is 4. So those numbers come from that. How do you get the middle number? Well, it comes from these two numbers as well. So there's an x and a 2. Well, it turns out that it comes from taking the middle. Multiply the middle numbers. X times 2. Okay? So this is where all the numbers come from then. You got x cubed, take the cube root, you get x. Cube root of 8 is 2. Now you start with x. Square both of these. Square x, you get x squared. Square 2, you get 2 squared. That's 4. And the middle number is taking these two numbers and multiplying together. All that's left is making sure we understand where the signs come from. You'll see here that x cubed plus 8 produces a factor of x plus 2. That's because the root is negative. Now this then is the same sign as this. It'll always be the case. This is the opposite sign. And that will always be the case. And so that's the pattern or the gimmick that works every time when I have to do the sum or differences of cubes. It's going to work with subtract as well. So we can come up then with an in general case. So there we go. We see x cubed plus y cubed. You take the cube root of the first. Okay, cube root of the first, cube root of the second, get answers. The sign is the same. Then you take your answers here, square this one, you get x squared. Square this one, you get y squared. Take the two of them and multiply them together, you get the middle, and this sign is opposite to what you started with. So naturally then, if you've got x cubed minus y cubed, cube root of the first, cube root of the second, keep the sign the same. It'll be minus. Take those answers, square the first one, you get x squared. Square this last one. Notice it's a negative y squared, it becomes plus. And then take the two of them, multiply them together, xy, but the sign is opposite. So let's do the first one together and then we'll give you a chance to try some of these on your own. So A, 125x cubed plus 8y cubed. Following the pattern. Square root of the first, 5x. Square root of the second, the cube root of 8, it's the cube of the first, cube root of the second. Cube root of the first is 5x, cube root of the second is 2y, and the sign is the same. Now I have those answers. I'm going to square them. So 5x squared is 25x squared. 2y squared, that's going to go at the end, is 4y squared. In between, I got to multiply them. 5 times 2 is 10. So it's 10xy. And this sign is going to be opposite. Notice the final sign is always going to be positive because you're going to square this at the beginning. And if you're squaring this, you'll get a positive. If it's a negative, you square it, it's still going to be positive. So that part's, this number here is always going to be positive. This one will be the opposite of the question. So I'll give you a second if you want to push pause again. You can try the next two. Okay, so answer the next one then. Cube root of the first. Cube root of 27 is 3. 3 times 3 is 9 times 3 is 27. Yeah, so 3x. Cube root of 512 off the top of my head is 8. 8 times 8 times 8. Same sign. Square it. We get 3x squared is 9x squared. At the end, the squaring negative 8 is plus 64. And in the middle, it is, multiplying them together, is 24x and the sign is opposite. Last one, cube root of the first. So this one might be a little bit challenging. Cube root of m to the power 6. So what numbers do I multiply 3 times to get m to the power 6? Well, it's got to be m squared. M squared times m squared times m squared is 2 plus 2 plus 2 is 6. It's m squared. Here, cube root of 1 over 27. Well, it's you just take the cube root of the top and cube root of the bottom. Cube root of the top is 1. Cube root of the bottom is 3. And it's n. Keep the sign the same. Second part, square the first, square the second. So m squared, and then square that is m to the power 4. 1/3 n, even though it's negative, when you square it, it'll become positive. So it'll be 1/9 n squared. And now in the middle, you multiply them together. That's 1/3 m squared n. And the sign is opposite. So that's the idea. The questions do get a little bit more challenging in that we could ask you to do something like this, which is going to be the same process, but just going to take longer. Okay. You'll see that this is difference of cubes. It's just the cubed number isn't like a pretty number like 81 or 27 or whatever. It's a bracket, but that's fine. The process is still going to hold true. So let's just watch and copy as we go along here. I'm going to need some space. So process still the same. Cube root of the first, cube root of the second. So it's something being cubed, so of course the cube root of it must be that something, a plus 3. Same with the other thing is the cube root of something being cubed is just 2a plus 1. Keep the sign. The second part, and I'm using square brackets so that I can still see my pattern. I'm going to square the first. So I take the first thing, which is a plus 3, and I'm going to square it. I'm going to skip all the way to the end, square the second, and it's 2a plus 1 squared. The middle term comes from multiplying those two together. So if I multiply them, it looks like this, a plus 3 times 2a plus 1, and the sign is opposite. So we've actually followed the exact same pattern. The only difference in these questions is you can now actually simplify it a little bit. So the front bracket here can actually be simplified, and the other ones we usually didn't simplify because we had unlike terms. You see, you didn't simplify here or here because they're unlike terms. Same with down here. There's no simplifying to do because you have unlike terms. But in this sort of unique question, you can actually simplify because you do have like terms. So I'm going to do that. It's a plus 3, and I'm subtracting this, which means I have to subtract both terms in there. Oh, sorry, that should be a square bracket. A plus 3 minus 2a minus 1. Okay, square brackets. Here, I can simplify a plus 3 squared. It's a plus 3 times a plus 3. So that's a cubed plus 3a plus 3a plus 9. Okay, minus, I'm going to rainbow here, 2a squared plus a plus 6a plus 3 plus, and you can see I slowly running out of room. Let's see if I can squeeze this in. This is going to be 4a squared plus 2a plus 2a plus 1. Again, verify that. Remember, this means 2a plus 1 times 2a plus 1. So rainbow, 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 rainbow. Simplify over here. I've got a minus 2a is negative a. 3 minus 1 is 2. Over here, we can do a little bit of simplifying. a cubed plus 6a plus 9. I'm going to have to rainbow this negative in a whole bunch of times. Minus 2a squared minus a minus 6a minus 3. Actually, rainbow 4 times. Plus, I can do some collecting, 4a squared. Collect those, plus 4a plus 1. And that's the whole second half of my brackets. And really this is big, long, not very exciting work, but it's another way to practice this. A cubed doesn't have anything, so it's just that. Got a bunch of a squareds plus 2a squared. And I've got a 6a minus a, so I'm at 5. Minus 6 is at minus 1. And plus 4 is plus 3a. Did I do that right? Yeah, it looks good. And then my final steps are the constants. And I've got 9 minus 3 is 6, plus 1 is 7. Okay, so just double check that I haven't made some silly mistake there. But what's most important is this. That's practicing your sums and differences squares, or cubes. Okay. So I'm going to stop the video here, but I'm going to double check my math, and if I make an error, I'll tell you. You'll probably have already noticed any errors, but I'll tell you tomorrow if I've found an error. So what are we going to practice now for the rest of class? Page 182. Numbers 2 to 5. All right, thanks very much.